A set of natural numbers define a relation on n as A is related to B if and only if A plus B is even for all A and B coming from set of natural number. Then option A is R is an equivalence relation. Option B is these are only two class of not of classes with respect to this relation. Class equation of 2 intersection class equation of 1 is empty, and intersection of class equation 3 and 5 is empty. So we have to tell about all these four options. As two natural numbers, if they are related, they will satisfy, their sum will be even. So we check reflexive property. So consider an natural number. So A will be related to itself if and only if A plus A is even, because of A plus A is 2A, and we know that 2A has 2 is a factor. 2A has a factor 2, so it is a even number. So this is true for every natural number. So relation is reflexive. Now need to check symmetric. So if A is related to B, it means that this implies A plus B is even. If A plus B is even by the commutative property of natural numbers, I can write B plus A is equal to A plus B, and this means that this sum is also even, and hence I can say B is related to A. So symmetric property is satisfied. Now need to check transitive property. So relation will be transitive if A is related to B and B is related to C, then A is related to C. If this property satisfy, we will say relation is transitive. So check that if A is related to B and B is related to C, then we need to check that is A is related to C or not. If A is related to B, it means A plus B is even, and B is related to C, it means that B plus C is even. Now consider cases. If sum is even, it means that both A and B is either odd or even. If they are even, then it has 2n type format. If they are odd, then it will have 2n plus 1 format. So in both case, resultant will be even because of 1 plus 1 make 2, and 2 2 is this 2 will be factor in both terms, so sum will be even. In this also same reasoning here. Now it means that A is related to B and B is related to C. It means that both, if A is odd, then B is odd, then B is odd, then C is odd. Means A, B and C, all these are odd. If A is even, then B is even, then B is even, then C is also. So A, B, C is even. In first case odd, and second case you can consider even. In both cases, sum of even and odd, you can see we need to check that relation is holding in A, between A and C. It means that if A and C are odd, both odd, then their sum will be even. If A and C both are even, then their sum is also again even number. Means A and C are related, so relation is transitive. So I can say relation is equivalence relation. Now need to check class equation of 2, 1, 3 and 5. This class equation has non-empty, intersection as a non-empty. So class equation of any natural number, n is referring for natural number. So in this class equation, all those natural number will come in this class equation, which are or their sum with n is even. Their sum is even, so I can say that if n is odd, then m is odd, m must be odd. If n is even, then m is even. So we have two class equation. One is saying that class equation is either by even or odd. So I can say that class equation of odd can be generated by one, class equation of any odd, if this is odd, can be generated by one, and the class equation of any natural number which is an even number can be generated by two. So basically we have two types of classification: classification of 1 and classification of 2. So and these are because of even and odd, so their intersection will be null set or empty set. So you can see classification of 1 and 2 in option C, this is true, and classification of 3 and 5, because of these two are odd, so their classification cannot be empty set. So first option and second and third, these are true options.